Hello, welcome back. So this is a video that will be some feedback on the ED quiz you just did. I'm going to go through some of the worst answered questions on the quiz. Then I'm going to post another quiz for you to have a go at on Friday, which should be the day you watch this. And then we'll see how we do from there. Okay, so this first question is asking us for the distance travelled. And we've got a speed graph here, so when we've got a speed graph and we want to find the distance travelled, we're going to find the area underneath. So it's between 6 and 8 seconds. So 6 seconds is here. I'm going to draw until I hit my graph at this point here. And 8 seconds, I'm going to do the same. And then I'm going to complete that shape and make a trapezium. And we're going to find the area of this. It's an estimate. It's an estimate because it's not exactly as this curve. We can see it's going to be a slight overestimate actually, so our answers should be a little bit bigger once we get it. So finding the area of this, well, first of all I need to spot, I think this is going to be roughly going up to about 9 on my axis, and this is going to be going up to about 15 on my axis, and we've got a width here of 2. So the area of a trapezium, we add the parallel sides, divide it by 2, and then times it by the height, which is 2. That is just going to leave us with 9 plus 15, because the minus 2 and the times by 2 will cancel. So it just leaves us with 24. I got it bang on there. That's probably because I didn't read off the stuff so much. That's probably more like 9.5, which would have put it a little bit higher. But we can see that we'd have got kind of roughly the right thing there. So having a go at question 2. Oh, this isn't question 2. I don't know what Srek's doing, but he kind of vibing though. Alright, so we'll go on to question 3. I'll cut that out in post because I don't know why that was in there. Question 3. What does the gradient of the curve represent? Well, the curve represents the velocity, so the gradient of the curve is the change in the velocity, which when we think about the change in distance over time, that's the speed. But if we do velocity over time, that shows our acceleration, how much our velocity changes. I like to think of these little flowcharts. So if we're finding the gradient, if we find the gradient of a distance curve, it finds the speed or velocity. And if we find the gradient of a speed or velocity curve, it finds the acceleration. And then going the other way, if we find the area underneath an acceleration curve, it brings us back to the speed. And if we find the area underneath a speed velocity curve, it brings us back to the distance. The difference between speed and velocity is, well, if we're talking about speed, it doesn't have a direction. So if we go walking to school, we're going 2 miles per hour this way from home to school. So our speed would be 2 miles per hour. If you go home at the same speed of 2 miles per hour, your speed would still just be called 2 miles per hour. But your velocity we need to state which way is positive. So I'm going to say from home to school is a positive movement. So your journey to school, so going this way, I would class that as, well, that would be called a velocity of 2 miles an hour. If we were going home, that would be a velocity of negative 2 miles an hour. So a velocity has a direction. So in this case, we're talking about velocity. The person's always going forwards, but we could see at some stages that the graph could come down here. It could drop all the way down and start going below the axis. You'll very rarely see that at GCSE, but it can do. Okay. Graph shows the information about the velocity of a parachutist. Which of the following is the best estimate of the gradient? So just pick some points that are roughly nice. So I'm going to pick here, and probably here. Draw yourself a little triangle, and you need to find the change in the y coordinates and the change in the x coordinates, and the gradient, which we call m, is going to be change in y over change in x. So 32, that's roughly 55, so the change is going to be 25. This x coordinate is 2, the new x coordinate is 8, so that's going to be 25 and 6. So 25 over 6 gives me roughly about 4.16, so I will say my answer here is 4. What is the best estimate for the speed? So by speed, because it's a distance graph, finding the gradient of a distance graph gives us the speed. So it's really saying what is the best estimate of the gradient here. Let's pick the point 0, 0, and let's pick the point 6, 20. So again, we're going to do change in our y value over change in our x value to find the gradient. Change in our y value is 20, change in our x value is 6. That is going to give me 3 point something. So our best estimate here is 3.3 recurring. Okay. Finding the acceleration. This was under the area under the curve section, but it wasn't asking you to find an area under a curve. The gradient of a velocity graph gives us the acceleration, because the acceleration is how much our speed changes over time. So, and it's of section A. So we want to find just the gradient of this line. That is going to be 20 by 10. So speed, an acceleration of 2. Velocity time graph shows this. What is the distance travelled? Well, the distance travelled this time, we're going to find the area, because we're finding the distance from a velocity graph. So it's going to be 20 times by 10 over 2 area of a triangle gives me 100. Find the distance travelled, so we know we're going to be talking about area. We need to find the speed this time, but the distance travelled is 50. So when we find the area, that's going to be equal to 50. So we're going to find this in terms of v. So it's got a base of 4, a height of v. So 4 times v over 2 equals to 50, because this would equal to the distance, and that is the distance travelled. So 2v equals to 50. V equals to 25. A bit of forming and solving equations there, which we've done before. And this final one, I think, a lot of us went for 900 because we found the area of this section and we just did 20 times 45. Problem is here, this is miles per hour and this is minutes. So you need to say that 45 mins equals to 0.7 hours. You can find that by just doing 45 over 60. You can do that with any minutes. Over 60 will give you the decimal hours. So then I'm going to do 20 times 0.75, which gives me 15. And a very important slide. Why are your grades slipping? Less memes. More work. I think I could tell that to myself as well. And that's it for today. Thank you very much.